Okay, guys, we are back. I prepared some, well, a couple of rendering with the two different values for occlusion amount. Just to recap this ambient occlusion thing, with radius, you define how far from the concavity the ambient occlusion effect is being calculated. And with the occlusion amount, you basically increase the density of the darkness. Okay, so I prepared two scenes. One is, well, I kept the radius to 8, and I just changed the occlusion amount from 0.8, which is this image here, to 1.5, which is this other one. So you see how just with 1.5, we already have a dramatic effect with ambient occlusion. I would say that this is already too much for our scene. Eventually, 0.8 is still bearable as a result, but I would, in my personal opinion, with my personal taste for imaging, I would also decrease this to something like 0.5, for example, because I already have the effect with 0.8 of the shadows that diffuse shadow that Boshenk was saying, but I would eventually prefer a brighter look for this image. But anyway, this becomes like very personal. Okay, so let me get rid of this. Yep, and let's turn off history. And let's go back to our 0.8 value for ambient occlusion. Okay. Next, I would say that these frames also need some material, but this is quite easy. I will give this some kind of, I don't know, some polished frame with some gray. Let's keep this scene with some controlled color scale or color range. So I would avoid like extremely brilliant colors and something like that. So let's concentrate on the frames. The problem with this model here is that selecting the parts as they are all exploded, you have to struggle a little, but in the end, it's not that complicated. The important thing is the outer frame, not the back frame, of course, because it is invisible. So I would select this and also this and this. So we have all the frames selected. And once again, in order to have them more easily selectable later on, I will change the display color to something, I don't know, green. So it would be easier for me to select them later on. And let's select one. Let's select by color. Let's go into V-Ray settings. Let's go into the material area here. Oh, by the way, I forgot that the floor tiles here are too small, actually, because we didn't change the amount of repetition, horizontal and vertical. We need to lower this to 2 by 2. Just remember that if you do this into one texture in one aspect of the material, you have to tweak also the other aspect that rely on the same texture, because else you have tiles that measure, in this case, in our case, 25, but the bump is still calibrated for 12.5 size of our tiles. So we must go also into the bump map and lower this to 2 by 2. And now we will have a perfect correspondence between the tile and the mortar effect. Okay, so now the frame. I will use another generic material. This is going to be a very simple material. So this is going to be a painting frame. And it's going to be a darker gray. And remember that in real life, well, I would say that all materials are reflective, all of them. So never avoid giving some reflection to materials. Okay. Now you can decide how to behave with reflection. You can increase reflection to its maximum and then eventually make the material very glossy. As I told you, don't ever go below 0.6 or 0.5. Or you can also decide to have a glossy finish, but a less reflective material. Okay. In this case, I want to create some kind of painted wood for this kind of frame. So this is already good enough. Eventually, I can tweak between the two settings. I would prefer some low amount of reflection and also a little bit of lower reflection glossiness in order to have this kind of effect. Okay, and that's it. I just apply this to the selection. So when you work with a uniform and let's say smooth material or polished material, working with generic materials is probably one of the best options. Even if you might want to experiment a little with experiment a little with PBR, which is perfect for this kind of object. But everything can be obtained starting with a generic material. Okay. I want to do something very peculiar right now. So in order to start introducing also textured material, real textured material, well, in terms of materials, every material is textured somehow. So procedural material means that also textures are created procedurally, which is what we have been doing so far, right? When you think about textured material, normally you refer to external assets. So textured images that you eventually have in your image library or material library, or you have bought some material collections, they almost all rely on external assets, which are normally raster images like JPEG or PNG or whatever. So in order to introduce this, I'm going to create a very, very specific behavior for our one of our material. And I'm going to do this with, well, eventually we can do this with a glass material. But yeah, with glass materials, it's okay. Yeah, let's work with glasses. What I want to do, I want to simulate the fact that one glass panel between these has a some kind of variation in the reflection aspect. So, for example, like a fingerprint or something like that, okay? Or it could be some dirt or you know, something that makes this window or this glass look less fake or less perfect, okay? So what I'm going to do, I'm going to lock all the rest, and I'm going to ungroup these glasses again, just in order to isolate one and work with it. And as always, I'm going to copy this panel, place it here floating around, and orient it towards one of the windows that are here, so I can concentrate on it and render it in real time. And yeah, something like this. Oh, you see, for example, when I zoom in, this object tends to disappear. Now, this is not a real problem. I mean, if you have this situation, you don't see the object, but you go into V-Ray Interactive, or you make a standard render, the object will still be here. It's not that it is totally gone. Let me see if we can detect at least some reflection for this, because else it becomes very difficult for us to work on the material. So here's the object. Let's see if we can get some nice reflection. Here it is. Okay, you see that the object is still here, even if in our scene, in our viewport, it becomes invisible. You see that now it is visible. You see the yellow selection. But if I go closer, the object, it becomes invisible. This is due to, well, it's basically is the graphic card, actually. And this happens because my scene is too wide. Okay, so this small detail cannot be rendered by the graphic card because the graphic card is occupied in rendering all this thing here, which is the one thing that I placed also yesterday at night, which is the V-Ray infinite plane. Now, as the scene has become this large, then the graphic card has some problems rendering the smaller objects. Okay, but this doesn't mean that the object is not present. As you can see, I have this reflection here, so everything is working properly. Okay, now what I want to do, I want to concentrate on that object, look through it across this window, and as I'm working with a box, I could also decrease its size, but I won't. I just want to concentrate on a particular corner of this object. So I am trying to take a look at this particular corner. And in order to be sure, I will activate the camera and I will do something like this. Take the camera target, move it like here, move it like with correspondence to this corner here, and eventually lower it down to exactly look at the corner of this glass panel. So my glass panel is actually here. And what I want to do, I want to distribute some irregularity over the surface of this glass panel. So what I'm doing right now is this. Let me deactivate the camera, and let's go into V-Ray Asset Editor, and let's go into, well, glass, actually. We could also work with glass smoky if you want to. We can do this because this will make our object, well, more visible. So let me see. You see the corner of this mirror here. Let's see if we can. Oh, it was not selected. Eventually, that's why I didn't get the material applied. So apply to selection. And yes, here it is. Okay, so what I want right now is to apply some imperfection over this thing. Now, glass smoky, I would eventually duplicate this material and let's call it glass smoky fingerprint. Okay, so let's introduce texture material like this in a very, let's say, scenographic way. So I'm going to Google something. I'm going to Google fingerprint texture. Normally, this is what you do. You go and look for something texture, and you will have access to lots of material. So depending on, according on how much texture you want to apply to this object, if you want to simulate a glass that has been manipulated quite much, you can take this kind of texture right now. So I think this is quite good for us. You should also pay attention to the size of this. We will discuss this in a while. You open this in a new window because this is actually Google Preview. It's not the actual image. So if this image is accessible, then by opening it in a new tab, you will eventually have access to the actual image. So you see that this is the actual size for this image. And then I save this image. I will save it inside our folder, which is not this one, is this one. And yeah, Fingerprint 01 is a good name. It's recognizable enough. So now we have this texture, right? And what I want to do, I want to apply this texture over this object. Where do I apply the texture? Well, you must think about where in real life you have this effect. The effect happens on the surface of the glass. So the thing that is affected is reflection, actually. So you must use this texture in your reflection channel. And what is this texture affecting? Is it affecting the amount of reflection? I wouldn't say so, because fingerprint are actually, well, let's say a layer of I don't know, something like moisture or sweat or something that you just deposit on the surface of something. So it's not the amount of reflection, it's the quality of the reflection that is affected. So I would say that reflection glossiness is a good parameter for this. So in this case, you must add something to a texture slot, and this time it's going to be a bitmap. And this bitmap is going to be our fingerprint 01. Okay? So like this. Now, this bitmap is black and white. And remember that we are mapping the glossiness channel, where white means perfectly glossy, while black means that glossiness is totally, well, actually absent. So the material becomes absolutely matte. Or reflections start to be extremely diffused, okay? So what we want is the opposite. We want the fingerprint to produce some kind of, to reduce glossiness, and black to leave glossiness intact, okay? So if we go inside this texture, there is color manipulation that allows to do some, let's say, um, basic color manipulation. Okay, don't think about this like extreme power in your hands. If you want to edit and change texture, you must work into some photo editing software like Photoshop or whatever, or GIMP, which is actually a good open source software. But you can invert the texture. So if I invert the texture, I have the opposite. I have a globally white texture with some black or gray areas, which corresponds to the fingertips. This is the opposite. My object will be tendentially like perfectly reflective with glossiness, and there are some spots where the reflection will be lower because of the diffusion that happens because of the fingerprints. Now, we are working with a procedural material, which is glass, but we added a texture in the reflection glossiness. And therefore, we need texture mapping over the object, okay? So if this is already applied to this, and we did apply it already, but just in order to be sure, here it is again. And what I need to do now is map my material and texture eventually over this, this object. I go into the object property, texture mapping, what type of texture mapping I will apply to this. The only texture that I need to map on this are the fingerprints. So I need the fingerprints to be aligned to this face. And then also a standard planar mapping would work. So I would switch to wireframe, take a look at these like in a better representation. You see that if I, for example, let's unlock everything, and instead of doing this, I will hide everything else. So now I think, yeah, I can zoom in as much as I want, you see? So because I eliminated the wide geometry in my scene. So I need to concentrate on this object, so I need to zoom in quite much. So I isolate it, and then now I switch to texture mapping and apply a planar mapping. But this time, I will apply planar mapping like 3-point or vertical, which is basically the same because my object is vertical. So vertical means what is the start of the edge of my mapping widget is this one. The end of edge is going to be this corner here, and the height is going to correspond to the height of this thing. Now, one problem is that our texture is more or less square, while my glass panel is more or less vertical rectangular. So I am stretching in this moment the texture vertically quite much. So the fingerprints will be stretched vertically, okay? But it doesn't matter, it's just for, let's say, starting to work with this kind of techniques. So bear with this. So I'm going back to this situation, and I'm going back to a V-Ray interactive render. Let's see if we start seeing something already. Remember that this is reflection glossiness, so it doesn't affect transparency. Okay, transparency is still perfect. Okay, it affects only reflection. So if I manage to catch some reflection on this thing, I should start seeing the fingerprints on the surface of this object. And you see here that we have some blurred reflection in these areas, which means that actually the object it has become reflective, but with fingerprints already acting like they should. Okay, so it's a very nice effect that you can create over the surface of your object. The problem is that you are starting to work with textured material, like with external assets. Okay, and this is something that tends to be difficult because the shape of our object is not always a flat box like this one. Okay, so the problem with working with textured material is not related to building the material itself, because it is based on external assets and the assets are already available, but how do you map the textures over the surface of the material? So this is something that we are going to discuss tomorrow, because it's quite complex. I prefer today to concentrate on this hybrid material between procedural and texture, with some simple texture placing or mapping over simple surfaces like this one. So you already see that this thing is already dirt enough with some ugly fingertips. Now, if you fingerprints, sorry, if you don't want this to be this look this bad in terms of dirt, then you go back in your V-Ray asset editor. The texture is here, and you can also tweak things a little. You can, for example, change the, well, actually this is working the opposite. This is making the things worse, because we are eliminating also the white glossiness. So everything is becoming here non-glossy, okay? So it's the opposite thing. You should eventually try to, yeah, exactly, reduce the darkness of the fingerprints. This is what happens here. But remember that tweaking the texture inside the V-Ray asset editor has a very limited potential. So if you want, you should eventually manipulate the texture outside from V-Ray, and then simply V-Ray will reload the updated version of the file. Yeah, as soon as you save it, V-Ray will reload it. So it's instantaneous. But yeah, we have a different behavior now. Now, what I want to do instead is apply this as another type of effect, where I want this this object here to have a transparency effect and not a reflection effect. So I want this phenomenon here of the fingerprints to be visible through the glass and not only on the glass. And so I simply remember that we are working with this texture. The material is already mapped on the surface of this object. I go back to my material, and I have also refraction. So refraction works that if the reflection color is white, the object is perfectly transparent. If it is black, it's totally matte, and light doesn't pass through the object. So with this in mind, let's go into texture. Let's take exactly the same bitmap. And what happens right now is that the object is globally, let's say, black, and only with correspondence to the fingerprints, we have this, this object transparent. So we only see through the glass where the fingerprints are, okay? Now, this is quite extreme, actually. Eventually, I want this to be the opposite. So once again, I invert the texture, and I start to see the fingerprints also in transparency, okay? And also, I can tweak the color gain in order to have this phenomenon less visible. Normally, you don't have this kind of visibility for fingerprints on a glass. You see them only from a specific perspective or angle, okay? But anyway, you see that we start to have this kind of nice behavior for our material. Here are our fingerprints on the surface of this glass. What's the problem when you work with textured material relying on external assets is that if I apply this material to these glass panels here, they will have the same fingerprints in the same exact position, all of them. So this is the problem when you work with external assets. They are always the same. And so it's difficult to produce variations, okay? But anyway, this is enough for this material, because I wanted to show you what's the potential that you have once you start working with texture. It would be the same to work inside V-Ray procedurally, but there is no fingerprint procedural texture, so it's basically impossible to do this. But you can use also procedural texture to do this. For example, if I switch back to wireframe, go back in the V-Ray assets, and go back to the material, okay? So I want this material to have a reflection glossiness affected not by a bitmap. So I go inside the texture and click here on bitmap, and I change it to some procedural texture like, I don't know. You also must be creative in terms of understanding how a procedural texture would help you with a specific effect. For example, I don't know, something like marble. Okay, so marble, what's marble? Marble is veins inside a background, over a background, okay? So if I take, for example, this texture and I want to use it right now, I'm using it for reflection glossiness, okay? So if I want this glass to have some areas which are not reflective, and areas of the glass, which is the background, which is totally reflective, I can use marble. And I can use, for example, color of vein is going to be a dark gray, or a gray that allows this kind of reflection diffusion, okay? So something like this. While globally the glass is going to be white, okay? So if I do this, I am applying a marble texture that will affect the reflection glossiness on this panel here. And so if I take a look at this object from the reflection side, which is going to be this side here, let's see if we already can see something, because now we should scale also the marble texture in order to get to the proper dimension. But we already see that we have some kind of glossiness, variable glossiness of this reflection over the surface of this glass panel, you see? And this is following actually the aspect of the veins inside the marble texture. So you can use whatever texture you want for defining each channel of your shader, but it should make sense actually, okay? Of course, the advantage is that if you have access to procedural texture, you should prefer procedural texture, because you avoid completely the repetitions or the tiling of the effect, okay? And tiling is something that you don't want to have in your rendering, okay? So you see how this glass panel is looking right now. This procedural material are quite interesting. So I eventually, like it is called Fingerprints, so I will switch this back to a bitmap, and it's going to be our fingerprints. We don't need to tweak anything but the invert and the color gain. So we are back to our previous result, and I will leave it like this. Of course, now, for example, that I want to share this file with you with this material inside, I need to share with you also the fingerprint texture, which is an external asset. If I don't share the asset with you, you open the Rhino file, you have this material, but this material is not going to find this asset in these two texture slots here. So you will not be able to see the actual aspect of this fingerprint stained material. But anyway, I'm not going to use it. As I told you, one thing is that should be interesting would be, instead of working with a glass panel like this, it should be to work with this round piece of glass in order to distribute fingerprints around a specific area, like if someone had taken this table and moved in this position. But this is a little more complex because of the mapping you need for this object. This is not a square object, so it's a circular object, and you need a specific custom texture mapping in order to work with it, okay? So I'm not going to do this today. We were going to do this tomorrow. So we will add fingerprints on the sides of this piece of glass. So this is actually a material that is not applied in our scene. Pay attention that if you, for example, push this button here, which is purge unused assets, this material will go away because it is not used inside your scene. Okay, so pay attention to this button here. If you don't want to lose assets, just don't click on this button, because else you are going to lose all the assets that are not actually in use inside your scene. Okay. Other procedural material that we need inside this scene, for example, the mug, this cup here. So this cup is going to be procedural. This is supposedly going to be some kind of ceramic material, porcelain, ceramic material, something like that. In this case, I would directly switch this scene from the interior to the close-up. I don't want to reload the V-Ray render settings right now, because they also have depth of field and a higher render output resolution, so render should last more, and I don't want this. I want to keep the workflow as smooth as possible. So I'm just changing the camera to this position. Okay, and what I want to do, I want to take this object, eventually take a look at your scene, because you might have this object exploded. Okay, so if it is exploded, you just select all the pieces and join them together into one single polysurface. Okay, so once it is a solid, I'm going to go into V-Ray Asset Editor, materials. I'm going to create a, let's take a look at the different shaders so that you know what happens with this, okay? So let's use, for example, a subsurface scattering. Remember that porcelain or ceramic are materials that have this kind of effect, the subsurface scattering, okay? Now, if you take this shader and you look at the preview, you already have an idea of what's going to happen, okay? So you see that the object, the material, has a very soft reflection on the external surface. But also, if you take a look at the inside, imagine that there is some light here on the back or somewhere, and you see that through the material you have this kind of shiny pinkish color. You see, this is the light passing through the object and filtering on the opposite face and creating this kind of luminescence here. Okay, and also you see that on the edges you have this kind of semi-transparency or translucency, which is defined by another color. Okay, so this is what happens with a subsurface scattering material. Light penetrates the first layer of an object. Of course, if the object is too thick, this effect will not get through. Okay, so you need thin materials in order to see this effect. If you don't have thin materials, the transparency or translucency simply goes away. So we have an object here which is not exactly thin, maybe, but for example, if you consider this part of the cup, there is no way that you can see this effect here, because you are only looking at the exterior face. You should eventually, if you want to see this type of effect, you should look at this object like from here, because if you look at from here, there will be light hitting the outer surface, and on the inside you should see some luminescence or some translucency. Okay, because the wall of this mug is thin enough. But at least we want to have some reflection, some smooth reflection effect on this on the handle. Okay, so what happens if I take this and apply this to this object? Okay, let's take a look at what happens. You see that it starts to, it looks like skin. Actually, it looks like human skin. Maybe this is the purpose of this default shader. Okay, but you have very smooth reflection, especially in this area, because there is translucency that blends together with reflection and gives you this aspect. Inside this kind of shader, there is also the possibility to add or to work with a specular layer. And there is a color which is white, which means it's reflective enough, but the amount is quite low, and also there is glossiness. Okay, so if you don't want a glossy reflection, you can increase this in order to create a perfectly polished reflection layer. And you can also increase the reflection amount by tweaking this value. For example, if I increase this, I will have a more effective reflection amount. But this is never going to look like a reflective material, because this shader is not meant to create this kind of reflection. Yes, you start to have some reflection going on, but it will never look like a perfectly reflective material. So even if I take a look at this from here, you will start to see that you have a reflection of the environment here in these areas, okay? But this is not like having a reflective material. So what you can do in this case, if you want a reflective material, you see that also, sorry, I didn't notice, I cannot exceed the amount of 1, okay? So this is the maximum reflection that you can get from this object. But eventually, you can take the subsurface scattering and start applying some other properties. Now, the shader, the subsurface scattering shader, only allows adding bump, displacement, some ray trace properties, some override, or material ID in case you want to use this in a multi-material shader. So there is no possibility to add additional reflection layers to this material, okay? So this is the limit that you have. When you go with a specific shader, you are stuck with the specific shader limits, in this case, reflection. Okay. What we can do with this, if you want this to look like porcelain or ceramic, of course you must change the diffuse color. It's not like this. I want a perfectly white cup. Also, you don't need this scattered color to be like cream. Okay, so also the scattered color is going to be white or a light gray eventually, if you wanted to make this effect a little more intense. Okay, and also subsurface color, the internal part of this object is not going to have a different material or a different color than the outer aspect, so like the diffuse layer. So I would set subsurface color also to white, because if you don't do this, you are considering the orange scale. So you still see this orange behavior for the material. So you need to set this to white as well. And now we have this ceramic or subsurface scattering material that starts to look like porcelain, okay, with some nice smooth behavior on the surface. Okay, that's it. That's what you can do with this kind of material. So if we go back to our default close-up scene, this is what we're getting, and it looks quite nice because the handle actually looks like translucent, because there is no particular difference between the brightness of this outer side of the handle and the brightness of the other side, because lights can penetrate, can pass through this wall here. And also, if eventually, if we take a look at this object, like in another close-up orientation, like for example from here, we should also be able to see some light filtering through the wall of this object. You see how this internal part here is bright and it's dark here because the light is actually hitting half the body of this cup and not this half. So this is a subsurface scattering material. And also you see the connection between the handle and the body of our mug, our cup. You see it becomes darker because there is more thickness in this area. So light cannot pass through this. And you see that the only thing that is missing here is a little more reflection, right? This is what we miss. So how can we do this when this subsurface scattering material doesn't allow adding reflection? Well, we can eventually use another approach to this. We can eventually, well, let's stop this, okay? So let's go to wireframe. And what I'm going to do, I'm going to create, well, this is, let's call it like, SSS. And I'm going to create a new, guess what, generic material. And I'm going to give this material perfectly white color. I want it to be reflective, and I want to apply this to this selection. So this is going to be porcelain. Well, this is going to be generic. Oops. Okay. So we are working with this, right? Now, take a look at this render, like from this point of view, with this simple material. Okay, now we have, well, quite a good reflection level. See how much reflection we are getting over the surface of this object. Also, let me go a little closer. So, yeah, like this. So the object is actually very reflective, okay? Also, these areas here are very reflective. What we miss, you see that this area is quite dark if compared to the part of the handle that it's hit directly by the sunlight, right? So we want to recover some subsurface scattering. Now, the problem with this is that the generic shader is not made for having this kind of subsurface scattering behavior. You might want to tweak this with refraction. So you might say, okay, let's say that subsurface scattering is somehow the light being capable of passing through the object. So we need some refraction, right? So if I do this, I start to make this object like more transparent. Okay. Problem is that, yeah, you see that now it has become like more bright in this area. And also, if we take a look at this cup from the inside, we might start to see something like the effects that we were getting. But you see that this thing here is transparent. So the shadow that is projected by the handle is perfectly visible because it is not scattering. There is no diffusion inside the object. It's pure transparency. So light travels through the object and it's deviated only by 1.6 index of refraction. Okay? So if you want to achieve the same result, eventually what you might want to do is take refraction, make it clearer like or brighter like with a dark gray, and at the same time reduce refraction glossiness. So if you do this, you say that refraction is not linear inside the object, but it's getting diffused. This is like reflection glossiness that tends to blur the reflection. This is refraction glossiness tends to blur refraction or transparency. So you see that now the shadows start to be a little less neat or sharp. And if we do this like with dramatic values, you will start to see that more or less you are getting the same effect as subsurface scattering. You see that this is the less, you have less translucence here because there is an object behind. It's not a matter of thickness in this case, it's just a matter of having something behind the other object, okay? And at the same time, we are maintaining the same level of reflection, okay? So this is something that eventually you might want to do to easily tweak a material to become some kind of subsurface scattering style material. Okay, but it's not correct. This is not physically correct. Okay, but in the end, in an image, what it matters is the result that you are getting. Okay, so we already got to quite a nice result. But in this shader, in this generic V-Ray material, there is also beyond below refraction, there is also opacity. And opacity has to deal with transparency, of course, okay, but in a different way. Now, this opacity here is something that many users, by mistake, interpret this like the transparency of the material, but it's not like that. This opacity affects the whole group of properties that we are setting here. Okay, so it's not like you use this in order to make this material more or less transparent. It's not like that. It's the effect of this V-Ray material group that is going to be affected by this opacity. Okay, so don't use this if you want to work with this kind of behavior. And you see that we already got to quite a nice result with the right amount of reflection. And also, in this case, if you work with a generic material, remember that reflection amount is determined by the reflection IOR. So if I want more reflection here, I can activate this and set this to, I don't know, 5. And we have this kind of, start to look like pearl material, because it is very reflective. But you see that the amount of reflection is now, well, of course I exaggerated just in order to show the effect, but you see what I'm talking about. We have control over the translucency and also over the reflection aspect. Okay, so yes, there are shaders that tend to simplify some processes, but if you need to tweak something, you might not have the possibility because of the limits that each shader has inside. Okay, so in this case, you can easily switch between the two. Just one consideration about the rendering time. If you work with refraction glossiness, render tends to be slower, because light scattering is a complex phenomenon that happens inside a material. And it doesn't matter if you work with refraction glossiness or with a SSS material, rendering time is going to increase because of this particular behavior. Okay. So this is quite a nice, let's say, material. And of course, if we, for example, start to let's say, if we want to have a good look at this rendering, we can now, for example, render it with a production rendering. Oh, by the way, and also we can reactivate depth of field in this case, because it is quite important in this kind of close-up. The same close-up without depth of field looks extremely dumb. There is no quality without depth of field if you do a close-up. And I think I should also tweak back the camera focus, because for some reason I think it moved. So I'm going to put my focus here on the edge. And also I'm going to take a look at the value here, 0.3. Yeah, it's quite enough. So let's render this. Oh, and also I can concentrate, too late. Sorry, my bad. I wanted to concentrate on the cup, but I will need to wait. Yeah, here it is. So I want to concentrate on this area of the rendering. Okay, light cache, and then the radiance map will start working. Here it is. Repass 101. Remember that we are working with mean rate, max rate at the same level, which is -2, which is already quite a good quality. Eh? I mean, this is -2 is something that I already use for production rendering. You might want to increase it to -1, but normally it's very unlikely that you need that kind of quality. Eventually, in a close-up, you might want to increase it, because all the details becomes very evident in a close-up. So you might want to increase the mean rate, max rate amount in this particular case. But for time needs, I won't do this. And so you see how these objects start to have translucency, the right reflection. See this white spot here is also intercepting the sun. So it's perfectly right, this image. And you have all the reflection of the environment on the surface of this cup. So yeah, pretty interesting. These are details. I mean, this is something like, I was telling you yesterday, is something like working with light colors, okay? So if you take a look at this image here, at this photo here, just don't pay attention to the fact that it's pixelating right now, because I'm zooming too much. But if you look at this image here, the color of the light is warm because of the sun. There is some cold light here because in this area there is the reflection of the sky, right? And then you have this defocus, this depth of field, and then there is this translucency here with this tiny little reflection occurring here on this part of the handle. So everything is perfect in this image. Even if we still lack materials and many things, but from a light point of view, this is absolutely perfect. You know, so the eye recognizes the equilibrium between all the aspects of this image. Okay. Let's go back to very stupid material in terms of textured material. So I'm going to slightly switch from between to slightly go from procedural material, fully procedural material to a totally textured material, like increasing this this complexity somehow. So I'm going to let's say get rid also of the depth of field because I don't want to see it anymore. And I'm going to go and map or give a material to this surface inside this picture frame here. And I'm going to use, I don't know, I like very much Pollock paintings. So I'm going to go into images and go into Pollock painting. And let's say I want to use something like this one. Let me take a look at the aspect ratio. It's more square-ish than rectangular. So eventually this would work. This also would work. This would work. So pay attention to also to the aspect ratio if you don't want to stretch things too much when you work with texture material. So eventually this one, let's see what's the size of this texture. Remember that when you work with a texture like external asset, the resolution should be high because resolution doesn't change during the rendering. So if you stretch a texture to cover a surface and then you make a close-up of that surface, you might look at the pixels. So the higher the resolution, the better result you will get, especially in close-ups. So I'm going to open this texture in another window. And I'm going to save this. Like, well, let's shrink this main Pollock painting. And that's it for now. Eventually, we are going to also, well, no, let's also take a vertical like this one. And yeah, here it is. And let's save it like Pollock painting, like vertical. Okay, so for now we can close Chrome. And let's go into V-Ray. And this is going to be very, very simple because I'm going to create a generic material like, rename it. It's going to be Pollock Paint Horizontal in order to clearly understand which is the horizontal and vertical. And I'm going to apply this to this painting, this surface here. And I'm going to diffuse color this time. And I'm going to take a bitmap. And the bitmap is going to be the horizontal painting. And here it is. And if everything is right, if I take this render here, we should see the painting with also the reflection. Oh, I forgot to deactivate the region rendering. It's in shadow, unfortunately, but this means that we can also directly go and give the right material to this surface here. And I'm going to simply duplicate the Pollock Paint H and rename it like Pollock Paint B. So this is going to have a different texture file, which is going to be this one. And I'm going back to the material, and I'm going to apply it to this selection. So if everything is correct, I should already have two Pollock paintings in my room. Here it is. Very nice. We have two Pollock paintings. Okay. You see that in this case, I didn't have to texture map two surfaces because the diffuse color, the standard texture mapping for a surface is the surface mapping. So having these two surfaces here with no mapping, no texture mapping at all, is the same as having this surface with a texture mapping like surface mapping. So actually what's happening is that the texture bitmap is being applied all over the extension of the surface itself. Okay, so this is why the texture is adapting to the size of the surface. So the only thing that you must pay attention in this case with a texture material like this is that the aspect ratio of the texture corresponds more or less to the aspect ratio of the surface that you are going to map with this material. Another thing that I want to do is apply also a floor, the same floor to the other room that's here. So I'm going to explode this and select the surface here. And this is going to be very easy. The only thing that I have to do right now, and you should know it perfectly, is take the floor tile material, apply it to that selection. The problem is that this selection here has no texture mapping. Okay, so the way that the same material is applied to this floor and to that floor there is different. Okay, so what I'm going to do, I'm going to select this surface. I'm going to go into surface texture mapping, and I'm going to say, okay, match mapping. I already have an object that has the same, the perfect mapping widget. So I'm going to match mapping, and Rhino says, okay, select the source object. I'm going to select this surface here. So this thing here is actually being mapped with the same mapping widget as this. And you can see the tiles also appearing in that area. Okay, next step, what I want to do, I want to give some material to the legs of this desk. So let's see if we have something else here. No, I would say that, oh yeah, this one, this guy here. I want this also to be like something like ceramic, but a different type. So I want to create another ceramic material, like for example, we have porcelain generic, right, which is this one. So if we duplicate this thing, well, actually, let's do something like this in order to differentiate this this material. I'm going to rename this porcelain generic like porcelain white generic, and this is going to be porcelain white SSS, and this is going to be renamed porcelain like black generic. Yeah, so I want black ceramic right now. Diffuse color, black. Now, I do not recommend you use perfect black in your material as diffuse color, because basically there is no difference between pure black and like, let's say, a very extremely dark gray. The only difference is that you might know that black diffusion means that all the light is absorbed by the material. So if you create a black material and you give no reflection to it, you are obtaining a black body. The black body is a theoretical physical body or object that doesn't let light escape its surface. Okay. So there is no black body in the real world or in our world, in our surroundings. Okay, so don't do that. You better take this. Eventually, if you want to have a precise control, you go inside this color here and take the value and increase it numerically if you want. but don't use a perfectly black diffuse color for your material. Okay, and also this is porcelain, so we want it to be reflective. Now there is still refraction here, and refraction color is set to gray, and there is basically also a huge amount of glossiness reduction here. So this might already do the trick. Oops, sorry, I think I didn't apply this material. Apply to selection. So that's it. That's all you have to do in this material. So let's go back to the Ray Interactive, which you see a black reflecting thing here, which is very undulated. So there might be some visible reflection also from the distance. But in any case, from in a close-up, it becomes quite visible. Yeah, there is some reflection in this particular spot, and also in this area here on the left, because it is reflecting the light projected on this wall. But anyway, it's already quite a good result. So next thing that I want to do is the wall. And I think this is the last thing that we are going to do for today. Now, speaking about the wall, as well as speaking about the floor, I didn't mention this thing while we were rendering the floor, because the main bounds that we have inside, light bounds that we have inside this scene, is the light entering this window and hitting the wall in this area. Okay, but when you give a color or a material to a surface like this, for example, there is direct light hitting this wall. So remember that when you have direct light hitting a surface, primary bounces or primary global illumination rays start from this surface. Then light can go bouncing around how many times we want to secondary rays like brute force, but their intensity, the secondary rays intensity, is way lower than the primary rays. So primary rays are quite powerful in terms of illumination power. Okay, and if the wall has some color, some diffuse color, the primary rays not only will have their power, but they'll also be colored light. Okay, because of the diffusion color. So what happens if I go in V-Ray assets and create a new material, like generic? I'm going to rename it like wall bat. And I'm going to take this and turn it red. And I'm going to simply apply it to selection. Okay. So I want to, of course, I'm exaggerating once again, but I want you to take a look at what happens in this case. So we have a red wall. Globally, the scene is getting darker because not all the light hitting that wall is being diffused by primary rays. Okay. Well, actually, yes, it is being diffused, but with a color that has more saturation, of course. It has a tone. So it's like if you take red, for example, and you convert it in grayscale, red becomes something like a mid to dark gray. Okay, so that's the light intensity that is actually being diffused by the primary rays of global illumination calculation. Okay, so this is why the scene becomes darker. Okay, this is actually what we were discussing since yesterday, first session, when we were overriding material with a gray material. Okay, so we were trying to anticipate this kind of global effect when you start working with material. Of course, red is not the right option. And another thing that I wanted to show you is this one. Maybe if we do this with a production rendering, it should become more visible. Well, I don't know if you are trained enough, but see these points here. These points are from the light cache calculation, right? And so light cache is over this wall, which is perfectly white, is already detecting some red primary bouncing hitting this wall. So basically, the result is that if you take a look at this wall here on the right, it is not perfectly white. It is something like pink, and it's getting red and red and red, more red as it gets close to the red wall that we have here. This thing here, this kind of this effect that we have, is called light bleeding or color bleeding. Actually, the wall is red, so it's actually bleeding. But bleeding has nothing to do with the color, of course. It's like the color of one object reaching the surface of another object and affecting its color. Okay, so that's why it's called bleeding. It's like this color spreads, like bleeds all over the scene. Okay. This is something that many people tends to say, oh, okay, I have this color and it's spreading all over the world. How can I avoid this? Well, first of all, if you have a red wall like this, and you have direct light hitting this wall, in real life, your whole room will become red. Okay, so this is not something that you must avoid. This is something that happens normally. And if it happens with a photorealistic rendering agent like V-Ray, rest assured that this phenomenon cannot be avoided. Okay, so basically there is no need to do this. And if you, for example, are working for a client, and the client say, "Oh, this looked too much red," then the right answer for the client is, "Oh, then avoid a perfectly red wall here, because this is what is going to look in your environment, in your built environment." Okay, so this is something that it's a continuous struggle between digital artists and clients. Okay, but this is something that is photorealistic. Okay, so it's this image from a photorealistic point of view is perfect. Now, if you want to avoid this kind of phenomenon here, there are some tweakings that you can do, but they are very, let's say, actually detailed tweakings. I'm not going to go too deep into details because V-Ray is almost infinite in this sense. But I want to give you some quick solutions. Well, actually, the bleeding is mostly affected in terms of material. Is mostly affected by saturation. Okay, so if you have a very saturated color, this saturation will be also diffused by the primary rays mostly. Okay, so you might want to desaturate a little your red in this case. Also, it's very difficult that someone perfectly healthy would select this kind of pure red color. This is basically 25500. Okay, so this is a color that nobody would pick like a color for a wall. Okay, but you can desaturate it. So you can go here and desaturate it a little. You see, so it becomes a little more dumber, like as a color. But this desaturation makes it less powerful during the rendering. Okay, so I'm going to exaggerate once again, but I want you to take a look at the result in this area. So let's render this. You see that basically we get the same red, more or less. There is almost no difference. You will see this when the rendering is finished. The eye detects this not like a desaturated red, detects it like a more light in the environment. Okay, eventually, but you see that it has no particular effect on the material itself. What it does is reduce the amount of red that you get over the scene itself. So once this ends, I'm going to get rid of the region rectangle, and I'm going to go here. And you might notice that you see that there is this line here. So you see that here the red is less intense than in this area. Okay, so you start to recover a white aspect for this wall. So personally, before starting to tweak V-Ray settings in a very specific way, What I would do is eventually tend to decrease the saturation in order to avoid excessive coloring of the primary bounces, which are the most effective bounces that you get in terms of illumination inside your environment. Oh, once again, I noticed later that there is some some side effect on some decision that we took. You see the floor? The floor is actually, it has actually become some kind of regular distribution of tiles, while initially it was random, right? So this is due to the fact that we this is important. So good that I noticed it. So this is the floor tiles. Okay. Now you see that also in the preview we already have this kind of strange behavior. Now what happens here? What happens is that we have created this kind of custom tiles with some color variants, okay? But we are allowing color variants only inside these 2x2 repetitions here. And so it means that this tile is going to be applied over and over and over because our mapping widget measures 50 by 50. So this is 50 by 50. So randomness is actually occurring into a region which is 50 by 50, which repeats itself several times. And so we have tiling or a repetition of the same pattern over and over and over. How can we create a totally random distribution of tiles over this floor? The only thing that we can do is actually, in this case, take this surface here, like this one, and we go and take some measurement, which is 10 by 5. Okay, so this is 10 by 5. If I want to place here in 10 by 5 meters, I want to place my tiles, which measure 25 centimeters, then it is going to be 10 meters, like 40 by 20. Okay, I need 40 by 20 tiles. And so I go inside the this texture here, and I say I want 40 by 20 tiles. Okay. Now you see this is distorted because the preview is square, but our surface is not. Okay. So I have this, and the variation actually is affecting all these texture here. And also, I also have to go back here and take the bump texture and say I want the same amount of repetition. Okay, and that's it. That's it for the material. Now, the problem is that if I take a look at this right now, I have 40 by 20 repetition inside 50 by 50 centimeters. Okay, so I must take this surface here, and instead of using this mapping widget that I have here, okay, which is I want to hide it, and also I want to get rid of the actual mapping. What I want to do, I want to apply a planar mapping to this surface, and the planar mapping is actually starting from the very beginning of this plane and reaching the opposite corner like this. So I created a mapping that covers the whole surface. And therefore, my 40 by 20 repetition now are going to adapt to the whole extension of the floor. So if we re-render this once again, oh, I think I must stop this because I had the, oh no, I just eliminated the region rendering. So yeah, we can do a interactive render. And we should see that actually the tiles will all look different. We no longer have this kind of pattern coming from the material. Okay, so when you map material over an object, the behavior of the material depends both on the texturing that you create inside the material and on the mapping rule that you determine in your texture mapping. Okay. Is it clear? Do you have any questions for what we saw up to this moment? Is everything clear? do you want to discuss something? If you don't,
just have a quick question. You previously mentioned that if it object is more organic shape, you will recommend using the sphere mapping. Is that correct?
Yeah, well, not exactly. It's a first approach. What I was saying is that the first option between what I said exactly is that if you have an organic shape like this one, and you want to use one of the automatic texture mapping that you have here, the more suitable probably is the sphere, because the sphere is the only geometry between cylinder, cube, and planar and plane that is capable of orienting in any direction in space, right? So this is the problem. Yeah, the sphere is actually the only option that you have between the default texture mapping object. But I also told you that when you have this kind of complex shape here, you must think about custom texture mapping. And this is something that we will see tomorrow, okay, in the next session, because this is going to be the more complex one in terms of mapping a material onto the surface of an object. So yes, if you want to map a material over a very complex object like this one, for example, then I would recommend you use a spherical texture mapping. For example, this one here, which is also organic, of course, but you see that more or less it fits exactly in a box. The third dimension, meaning the depth of this object, is quite irrelevant, right? So in this case, eventually, I would try with a box mapping. Okay. Any other question? Well, if you don't have any other question, let me just recap something. The two videos from yesterday's session are going to be uploaded right now. They are already rendered and available, so we are going to upload them on our YouTube channel. I once again, I don't know if you provided the email account that you use to access YouTube. If you didn't, just send us the right email, because else you won't be able to access the videos. They will be shared privately on YouTube, so we will use your YouTube email so that you can access YouTube and see those videos, okay? So if you didn't provide the YouTube email during the purchase process, please send us your YouTube email right now, because else you won't be able to watch these videos. It's going to be two videos because the rendering software that we use doesn't allow videos that are longer than 3 hours. So we split the yesterday's session into two videos. But they will be there and available. And we will share with you the link to those videos as soon as the upload finish. I don't know if you want, but we can also. Or what if I don't have a YouTube account? You create a YouTube account. This is the platform that we are using. Well, we are actually in the process of defining deciding if we switch to a Vimeo account. In that case, even in that case, you should need an account in order to access videos. So there is no other way. Basically, you need an account in any of this platform. Oh, there is a question, Surab. For a liquid material, should we use subsurface? It depends on the liquid. If the liquid is milk, for example, yes, absolutely. If the liquid is some colored liquid, no. For example, just because we are discussing, I have no problem in extending the class a few minutes. Okay, so I hope you can still yeah, let's say, resist some more minutes. Yeah, don't worry. So I would quickly draw something in order for you to better understand what I'm going to discuss. So please be patient a little. So I'm going to create some surface in order to approximate some shape. And just because we are doing this, let's do it like in a good way. So something like this, and something like this, and let's. I'm not paying too much attention to thickness and details, but it should be good enough for what we need. So I'm going to take this point and adjust their position. Just be patient. This is front view, so set X. I'm going to set X like here. And let's go and revolve this thing from here to here, full circle. Okay, so we have a cup. It's not the perfect cup, but it will do the work. So this is our object. And I want this to be, maybe I exaggerated a little. This is like a luxury cup for some expensive wine, but anyway, it's already enough for what we need. I'm going to hide this for a while, and I want this to be because I want you also to point out a particular problem that happens when you have transparent materials. Okay, so I'm just giving this object a glass material just so that we have our cup. It should be crystal or something, but it doesn't matter. So this is our first thing. Let's see if it looks good. Okay, here it is. Perfect. So what I want to do, I want to put some wine inside this object. Okay, wine is transparent and it's red. So what I'm going to do, first of all, let's create the object, because this is the tricky part. Okay, so wine is actually filling the cup in this area. Also, this thing looks very bad because of this thing here. So this is something I can quickly correct. And so let me do this. Yeah, this thickness was awful. So wine is actually a liquid that takes the shape, the internal shape of this cup here. So the quickest way to do this is basically copy paste the glass and eventually go into the surface creation tool and create a cutting plane that basically reaches the height where we want the wine to be, like this. Okay, now we have two cups here. I'm going to block one. I'm going to use this plane, this cutting plane here, to trim this cup. And I want to trim the lower part, which is this external part here, but also the higher part of the surface. And I just want to keep the internal part of this wine. I'm getting rid of this cutting plane. I'm taking this. Now, this object is a Revolution software surface, but it's not capped on top, okay? Because it comes from the trimming of the surface of the glass. And so what I'm doing is going in here and capping this upper hole. Now, this is the volume of our glass. The problem is, of wine, sorry. The problem is that this object is going to be transparent and the outer container is transparent too. Now, when you render something, you don't want to have coincident surfaces, because if you do this, the render engine doesn't know which surface to render first. And so if you do this, I'm going to take a look at this before applying wine material to this object, so that eventually we can already see what the problem is. But we should start to notice that there are some triangles happening now and then. I don't think that we are going to see this with these particular light conditions. There is a lot of reflection going on. Oh, and also because the inner material is steel glass. there is something happening here. You might notice that there are some crispy areas. This is due to the fact that we have two overlapping surfaces, okay? So this is something that you don't want to have in your rendering. So what's the best thing to do? You might think, okay, so I take this and scale it down. And if you do this, you start to obtain something, but the effect that you obtain is like, have you seen those eyeglasses with those lenses that are very, very thick, and your eye or the eye of the person that wears that glass seem to be very far behind the eyeglasses? This is what we are getting here. The glass is acting like a lens, and the content of the glass looks way smaller than it is. Well, actually, if you take a glass of water or wine or whatever, it looks like the one gets to the outer surface and it's not inside the glass. So the proper solution in this case is, yes, it's scaling the wine, but not inward, but outward. So having the wine here, like this. So this is like a trick that normally is used when you have this kind of transparent thing inside the transparent thing, and you see that now the surface of the liquid seems like it's reaching the outer border of our object, but actually it is not. It's like this. So this is the geometric trick that you must adopt when you want to render this kind of particular situation, okay? And now that we have the proper geometric settings, we go into V-Ray V-Ray assets, and I'm going to take the, well, it can be the glass or the glass smoky as well, because it is already prepared for being colored. So I duplicate this, and I'm going to call it just like wine. And I'm going to go into the refraction properties. Oh, and first of all, let's apply this to selection. So you see that the content is now basically black. And let's go into fog color. You see that fog color here is set to be in grayscale, but in the red tone. So you already see something here, but this is not the material. This is the reflection of the wall that's red, okay? So don't get confused about these effects here. We are still in grayscale, even if we are in the red tone, okay? So in order for this to become red, what I'm going to do, I'm going to take a look at this like from, also this is a very thick volume, okay? So any slight increase of saturation will determine this thing to become black, okay? So first of all, let's start with very light red tone. As you can see, this is becoming reddish. You see, this is like a rosé wine. But if we start to increase this, not too much, because we already have wine. See how slight variations determine a huge increment in the intensity of the fog color when you work with thick materials, okay? Once you get to the proper color, remember that you also have the fog multiplier here, okay? So we are using this pink here with a fog multiplier of 4. Normally this is set to 1, okay? But see how with this thickness, also a very slight increasing of the red tone already determine this kind of red aspect. If you do this, this becomes intense red, which is something that eventually starts to look like a Bordeaux or something like a red wine, properly red wine. Okay, so this is how you create colored liquid, okay, with fog color. There is something that we didn't discuss, but this we are going to discuss this tomorrow. That has to do with the proper, well, let's say not proper behavior, but you see that materials interact with light, right? The only interaction that we are considering in this moment between a material and light are basically diffusion, reflection, and refraction. But there are other effects that happen, that occur over materials when they interact with light. And tomorrow we are going to discuss these little details that make the difference between a normal rendering and a good rendering. Okay, so for today, I think we will finish with this cup of wine here, and tomorrow we will start from this eventually. Okay. So I think that's pretty it for today, and thank you for being here. This video is going to be uploaded. Later on today, or can you render that? What, this one? This scene? Yes, of course. Let me stop the interactive render like this, and I will render it from this point of view. Actually, let me save the scene. You never know when Windows is going to crash. So let me save the scene and let me production render this. You're not going to notice any relevant difference. The only thing that you would see eventually is the ambient occlusion contribution that will darken things up a little. But here it comes. I still have -2 as min-max in the irradiance map, so it's not going to be that fast, but anyway. Actually, it's going to be quite slow, as you can see. Well, while we're on this, as we are just waiting, you see these buckets here moving around in my scene. They are 8, and the amount of buckets depend on the amount of cores that you have in your CPU. So if you create a CPU rendering, like I'm doing right now, the amount of cores that you have corresponds to the amounts of contemporary buckets that you can render at the same time. And if you have more computers connected into the same network, via the swarm settings in the V-Ray settings, you can involve these other computers with their cores and their processors in the calculation. And in that case, you will have several more buckets in your rendering area. And so the rendering comes up quite fast. The only thing that I would eventually tweak in this case, in this rendering, is the floor, of course, because the mortar is actually out of scale with respect to the tiles. This depends on the fact that when I increase the amount of tiles, I didn't pay attention to the mortar, which is still, I think, 0.2, and therefore you have this kind of extreme separation between the tiles. But as per our glass of wine, I think it works quite well. What is not perfect in this case is the shadow of this thing, but this is quite normal. First of all, we are working with a very thin element here, which is also transparent. The sun is quite far. You see that the shadow of the frame are already blurred, so also the shadow is getting blurred, and it's very thin object. So that's why you see that it almost disappears on the surface of our desk. Okay, so this is the only thing that eventually I would like to tweak, but we still miss, for example, some caustic effects that will help increasing the interaction between this glass here and the desk.